Hello Math 8 students, this is Utah Middle School Math Project 7.1D, Simplifying Square Roots. This lesson is really a continuation of 7.1B and C, which were from the last video. Our focus for this video is going to be simplifying square roots. To review, I want you to take a look at what we did in our last video right here. We saw that the area of this square was 2, and since the area is 2, and since it's a square, we can find the side length. We take the square root of 2. And so the side length is not a nice number, it's just the square root of 2. But then we saw this a little bit bigger square, and we saw that this bigger square actually has 4 of those smaller squares. So again, remembering that the side length of the square is the square root of 2. That means this piece from here to here is a square root of 2, and this side length here, from here to here, is the square root of 2. So the square root of 2 plus the square root of 2, which we realize simplifies to 2 square roots of 2. Just like a cat plus a cat is 2 cats, a square root of 2 plus a square root of 2 is 2 square roots of 2. And then we go to this even larger square, and we see that this larger square contains multiple of the smaller square. So we see once again the square root of 2, 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 or in other words, we have 4 square roots of 2. But when I look at this in a different way, I can see that the area of this whole entire square is 32. So another way that I could write the side length is I can say, take the square root of the area, and we see that the side length could also be called the square root of 32. I want to pick up there. We did not get to spend a whole bunch of time doing this yesterday. Will you please go to your scratch pads in your calculator, clear it so we start with a nice fresh screen, but go to your scratch pad in your calculator. And in your scratch pad in your calculator, I want you to type in the square root of 32. And my calculator is still pulling up, so I'll show it on screen in just a second. But you guys type in the square root of 32. Yes, it gives you a big, long, ugly decimal, right? We talked about that before. That's an irrational number. And so when we have irrational numbers like that, we like to keep them in a nice form, like keeping it the square root of 32. However, we also like, even though we want it to be in a nice form, we want it to be simplified. There we go. And so the square root of 32, this big, long, ugly decimal. And we saw, based on this experiment with the area, that that side length, instead of written as the square root of 32, can be written as 4 square roots of 2, or 4 times the square root of 2. Type that into your calculator. 4 square root of 2. And you're going to see that it gives us the exact same big, long, ugly decimal. So this confirms these are equivalent. They're just 2 different ways of writing it. So what we're doing when we simplify the square roots is we make it look simpler. We don't want big numbers to be inside of that radical or inside of that square root symbol. We want it to be as small a number as possible. So we're going to learn today how we can transform this into the simplified version of this. One thing that is worth pointing out, this is 4 times the square root of 2. It is not the 4th root of 2. So I'm going to show both in the calculator. Do you see how those look different? This is an index of 4, meaning it would be how we undo a power of 4. Obviously, those are very, very different numbers, so make sure that when you see a 4 in front of a square root, you understand that that means 4 times the square root, which is different than an index of 4, the 4th root. Okay, with that in mind, let's learn how we can simplify these square roots. We kind of had a hint yesterday where I kind of reminded you that really what we ought to do is look for some factors of 8. And within the factors of 8, I found a perfect square. Within the factors of 32, I also found a perfect square. Now, I don't see that perfect square in the simplified version, but what is the square root of that perfect square? It's 2, and we do see that number there. Just like what is the square root of the perfect square 16? It's 4, and we do see that 4. So there are 2 different methods, 2 strategies that we can use to simplify square roots. I will show you both. You can decide whichever one you like better. Strategy 1 deals with finding a perfect square. So let's make sure we understand what a perfect square is. A perfect square happens when I take a whole number and square it. For example, 1 squared is equal to 1. 2 squared is equal to 4. That makes 4 a perfect square number. 3 squared is equal to 9. 9 is a perfect square. It's probably worthwhile to write these down so that you can easily identify those perfect squares. I'm going to go probably all the way up to 15. 4 squared is equal to 16. And 5 squared is equal to 25. So again, these are the perfect square numbers. They are very special numbers. Moving on, 6 squared is 36. Recognize that one. 7 squared is 49. 8 squared is 64. 9 squared is 81. And 10 squared is 100. Honestly, at this level, this is probably all that you will need to know, but it's a good idea to know 11 squared is 121. 12 squared, anyone know off the top of their head? Seth? Great job. How about 13 squared? Anyone know 13 squared? Close, 169. And 14 squared. This is one that I always struggle with and I can never remember. Thank you so much. 196, and 15 squared is 225. Recognize these perfect square numbers. So, method 1 or strategy 1 is find the greatest perfect square that is a factor of the number. For example, what we really need to do is factor what's inside of the radical, looking for perfect squares. Here's what I mean by that. Do you remember when we had the square root of 32? And when we did the square root of 32, we're like, hey, 2 and 16. And we also said 4 and 8. Either one of these have a perfect square. We want to look for the greatest perfect square. So which one of these two factorizations is going to be better? The 2 and the 16, because it has the greatest perfect square. Another example would be, I'm trying to think off the top of my head. Let's say 64. 64, an obvious factorization, looking for the things that multiply to be 64 would be 2 and 32. Are either of those perfect squares? Let's look at our numbers. Are either of those perfect squares? 2 and 32? No. So we want to look for other ones, like 4 and 16. Both of those are perfect squares, so that would be a little bit more helpful. So keep that in mind. First thing first, we're going to factor and we're going to look for perfect squares. The next step is we're going to rewrite those numbers inside of the square root symbols as the product of the greatest perfect square and the other factor. Here's what it looks like. Square root of 8. So let's start with 8. What are the factors of 8? 2 and 4. And do we see a perfect square? Yeah. So we're going to write the square root of 8, as you can already see. The square root of 8 is equal to the square root of 4 times 2. Nothing crazy there, right? We're just breaking 8 into its two factors. The next step, though, is square roots or radicals have really special properties where you can break them up. So the square root of 4 times 2, all together in one group, can be separated into two things. The square root of 4 times the square root of 2. And now we can simplify. What is the square root of 4? 2. So this becomes 2 times the square root of 2. And that's it. Let's try it with a bigger number. And yes, it's already all worked out for us, but all of these examples have been worked out. But let's go through that process again and again. The square root of 40, that means I'm going to stop and ask, what are the factors of 40? So we can start with 2 and 20. Are either of those perfect squares? No. So maybe let's try some different factors, like 4 and 10. Are any of those perfect squares? Yeah, 4 is. And so I'm going to write the square root of 40 as the square root of 4 times 10. Nothing crazy happening there. This is the only step that might be kind of weird, and you're going to learn more about why we can take this step when you are in 10th grade, but we can break those up into 2. So the square root of 4 times the square root of 10. And now, do we know the square root of 4? Yeah, square root of 4 is 2. And do we know the square root of 10? No, we actually don't, so we keep it the square root of 10, right? And so this simplifies to 2 times the square root of 10, or simply 2 square roots of 10. Again, the next one is done for you, but I'm not going to go over the square root of 32 and the square root of 45. I want you to take turns in partnerships at your groups, so you might need to break it up in tables of 3 into partnerships. Take turns explaining to your partner what is happening, and then the other person can do the square root of 45. We're going to pause the recording as students take the time to explain that. Ready, set, go. Okay. Before we do strategy 2, let's practice this. We've got a couple. Is this still on the same page for you, or is it the next page? It's the same page. Okay, let's try it with the square root of 50. Walk me through it. First, I should probably break up 50 into its factors. What are some factors of 50? Thank you, Danielle. 5 and 10. Are either of those perfect squares? No. So it works, yeah, but neither of them are perfect squares, so we might want to try something else. Dexton. 2 and 25. Are either of those perfect squares? Yeah, 2 is not, but 25 is. So that means I can rewrite the square root of 50 as the square root of 25 times 2. And once it's written like that, now I can break it up. The square root of 25 times the square root of 2. And now we can simplify. What is the square root of 25? 5. What is the square root of 2? The square root of 2. It's not 2. It's the square root of 2. And that's it. Not too hard, right? Okay. Let's skip to number 7, just so that we can make a connection. Do you see how we can break up multiplication into 2 separate radicals multiplied together? We can break up division the same way. So the square root of 4 25ths, we can break up to the square root of 4 divided by the square root of 25. And the square root of 4 is equal to 2. The square root of 25 is equal to 5. And so this simplifies to 2/5. All right, let's go back. Let's take a look at strategy 2. Strategy 2 has the benefit of sometimes we don't always find perfect squares. For example, the first factors that we thought of were 5 and 10. Are either of those perfect squares? No. So the benefit of strategy 2 is you don't have to just look for perfect squares. You're going to find all of the factors. So the truth is on number 1, you just make a factor tree and it helps if you go all the way down to its prime factors. After you find the factors, all of the factors, especially going down to the prime factors, you're going to look for and circle any pairs of numbers that you see. Now, let's take a look at what this looks like before we continue on with any of the other directions. So the square root of 8. It keeps all of these in radicals. I don't love keeping them in radicals. Maybe that's because I'm not following math practice 6 here, but I just want to focus on 8. And I'm going to start, I started factor trees here. I said 8 is 2 times 4, right? But we're not done factoring, especially because do we have any pairs? Do we have 2 of the same number yet? No. So I need to continue factoring. I usually focus on the non-primes. Like this, 4 is not prime. So what are the additional factors of 4? 2 and 2. This is our factor tree. And I want to look for any pairs. Do you see any numbers that we have 2 of? We have 3 2s, exactly. Notice though, I'm only looking, I'm going to highlight first, I'm only looking at the ends of the factor tree. If it's not at the end of a branch of that factor tree, I ignore it. Like the 4 is already broken up into 2 and 2. So I'm focusing on the 2 and the 2, not the 4. So do we see any pairs? Yes, we see a pair of 2s, and that's why they've circled that pair of 2s here. They're keeping everything in the radical. I am not. So what do we do with that? When I see a pair of 2s, what that really means is I have 2 to the second power, right? And I also have that multiplied by 2. 2 times 2 times 2 is 8, or 2 squared times 2 is 8. And now that I've kind of gotten that all worked out, all of that's equal to 8, I'm going to go ahead and take the time now. Let's put it all in a radical. So the square root of 8 is equal to the square root of 2 squared times 2. But really, truly, just like we saw over here, I can break up that radical, right? So I can rewrite that as, let me scroll so that everybody can see. I'm going to rewrite this in 2 separate radicals. So the square root of 2 squared times the square root of 2. Now, do you remember when we were solving our square root, or our equations involving squares, how a square and a square root would undo each other? That's exactly what's happening. This square and this square root, they undo each other. So what is it that I have left? 2. And what is it multiplied by? The square root of 2. So it's going to get us the same place, and some of the steps are the same, but instead of having to worry about finding that perfect square factor, you find the perfect square by going all the way down, finding all the factors, and just finding pairs. Let's take another look. Let's look at square root of 40 now. So again, we already know eventually it's going to simplify to 2 square roots of 10, or 2 times the square root of 10. But how do we do that? What are those steps? I'm going to try and squeeze it in here. What are the factors of 40? Give me any factor. It doesn't matter if it's a perfect square or not. In fact, I'm not even going to use this one here. Let's go with the other factors. Caden. Yes, but like I said, that one's already shown. So give me other ones. 20 and 2. 20 and 2. Any pairs yet? No, so let's keep going. 20 is not prime, so let's keep on going. What are some factors of 20? Brock. 2 and 10. Okay, do you see a pair? Yeah, there might be more pairs. So I found a pair, but let's keep looking. 10, what are the factors of 10? 2 and 5. Have we found any other pairs? Yeah? 5 and 2 is a pair? No, because it's not the same number, right? So we found a pair of 2s, a 2 and another 2. These are not a pair because it's not the same number. So what do we do with that information? Now I'm going to have to come over here. So after I make my factor tree, I'm going to rewrite that. Do you see how I have 2 times 2? That really means I have 2 squared. But what else do I have? Oh, right here. I have 5 and 2. So 2 squared times 5 times 2. Please understand what I'm doing here. All I'm doing is I'm breaking up that number. 2 squared times 2 times 5 is still 40. I'm just choosing, instead of writing the number 40, I'm writing it in this way. So the square root of 40 is equal to the square root of 2 squared times 5 times 2. Break it up though. The square root of 2 squared times the square root of, I could break that up into the square root of 5 times the square root of 2, but it's not necessary. Just keep it 5 times 2. And again, 2 squared, but then taking the square root of that, all that will be undone. The square and the square root undo each other, leaving me with just 2. 2 times the square root of, what do I have left inside of this? 5 times 2, which simplifies to 10. Okay. Practice it with 32 and 45. The work is already done for you. They've already found the factor trees, okay? But explain those steps to your group. Again, just like before, take turns sharing. So it's with partners, not with groups. Tables of 3, you can figure out how to do it so everybody has a turn who missed their turn last time. Ready, set, go. Let's put it to practice here with number 2. What are the factors of 200? You can give me any factors. You don't have to give me the perfect square factors. So what are the factors of 200? Sam? 20 and 10. I like that you went Instead of 2 and 100, you went for 20 and 10. I really like that. Are either of these perfect squares? No. So this is why it works really well for strategy 2. Sometimes the first factors that we come up with are not perfect squares. And so, let's keep going then. What are the factors of 10? Dexton. 5 and 2. What are the factors of 20? Brock. 2 and 10. Have we found a pair? Yeah, we're not done though. We haven't seen this yet. What are the factors of 10? 2 and 5. Do you see another pair? A pair that we wouldn't have seen if we would have stopped. So again, when I'm looking at pairs, I'm just focusing on the ends of the branches. So I'm highlighting all of those so that we can focus on the right spot to look at. Did we see a pair here? Yeah, but we broke that up even further. So what are the pairs that we see? I see a pair of 2s, and I see a pair of 5s. So that means I can rewrite the square root of 200 to be the square root of 2 squared, that takes care of this pair, times 5 squared, that takes care of this pair, times, don't forget about this one, times 2. Now let's break that up. I can break up that multiplication under the radical to be multiplication between radicals. I have the square root of 2 squared times the square root of 5 squared times the square root of 2. And now let's simplify. 2 is squared, but then we take the square root, so square and square root, undo. Do you see how we're multiplying? We're going to continue multiplying. The square root of 5 squared, the square and square root are inverses, so it's undone. So what am I left with? A 5. See how we're multiplying? We're still multiplying. What is the square root of 2? Does it simplify? Nope. Now, we're almost done. We didn't have this on any of the other problems, but we can simplify this outside. 2 times 5 is 10, so we end up with 10 square roots of 2. Let's just confirm in our calculators, because sometimes it's nice to just check and to confirm that we're doing this correctly. The square root of 200 is this big, long, ugly decimal. It's irrational. I just simplified the radical to be 10 square roots of 2, and the same big, long, ugly decimal. So they are equivalent. Let's, number 8, I think, is okay. Really, truly, it's just the square root of a perfect square divided by a perfect square. So on something like that, just handle it the way that we did on number 7. Only focus on the imperfect squares like 3 and 4 and those really interesting ones. We've tried each one now. I'm just curious. Who thinks that they like strategy 1 better? Okay. It's great if you know your perfect squares, right? If you can find perfect squares, it works every time. Strategy 2, who likes that strategy 2 better? Yeah, just keep on finding, keep going down all the way to the prime factors, find pairs. I personally prefer this way. This is the way that I learned it, so this is the way that I prefer it. That's the way I also did it with my 10th graders. So that's the way that I will probably show the work, especially since that's what the majority in this class says as well. Let's practice a few more. I'm going to not show how to do it. I want you to practice, and then we'll have students come up to the board. So focus now on 3, 4, and 5. If you have extra time, you can do some of these other ones, and maybe I'll go some of those other ones. So 3, 4, and 5 with your groups right now. Pause the recording as you work. Ready, set, go. Number 3, you should have gotten 6 square roots of 2. Any questions on that? Okay. Number 4, you should have gotten 7 square roots of 3. Are there any questions on that? Do you need me to go over that? There's talking, but no one's saying, yes, you need me to go over it? So we're good. Okay, I have not done number 5 yet. Who wants to tell their answer and see if it's correct? Gracie? Close. You're going to be close. Here's what I want you to be careful of. This is a question that Peyton had during the pause break. You probably did some correct steps, but look at the square root of 8. Could we continue to break up the square root of 8? 8 is equal to 2 times 4. So do we have another perfect square hidden in 8? Yeah. And so if you get to this point, Gracie, the 2 square roots of 8 is equal to 2 square roots of 4 times 2, which that can be further broken up to 2 square roots of 4 times the square root of 2. And what's the square root of 4? That's 2. So this is not 22, but 2 times 2 times the square root of 2, and 2 times 2 simplifies to 4 square roots of 2. How is that correct? I don't know. Yeah, it should be 8 square roots of 2 actually. Yeah. Yeah, this Gracie would be an approximation of the square root of something. I don't know. The square root of 32. This is the square root of 32. So should we go over number 5? Yeah, let's go over number 5 because this is not fully simplified. I do need voices off. If I'm going over it, there shouldn't be any talking. Thank you. The square root of 128. Let's find some factors of 128. I'm good to find any factors at all. What comes to your mind first, Sam? 4 and 23. 4 and 32. Okay. Why is there talking? Okay, I did find a perfect square, so that's good, right? But do you think it's the largest perfect square? So let's continue. Factors of 4 are 2 and 2. Factors of 32 are 8 and 4. But I'm still not done. 4 breaks down further. 8 breaks down further. And that breaks down even further, right? It is a lot of 2s. So again, we're only looking at the ends of the branches of our factor tree. And now that I've highlighted all of the ends, let's look for some pairs. There's a pair. There's a pair. There's a pair. Have I taken care of everything? No, we still have that too. But this means I have 2 squared. That takes care of this one. Times 2 squared. That takes care of this one. Times 2 squared. That takes care of this one. And times 2. That finally takes care of that last one. Yes, Brock. Remember, the pair of 4s is already taken care of in the 2s. That's why we focus on the ends of the branches. Highlight the ends of the branches of that factor tree so you know where to focus. Okay? So is there a way we could have done this differently? Yeah, but let's focus only on the ends just to keep things simple. So the square root of 128 is equal to the square root of 2 squared times 2 squared times 2 squared times 2. I break that up. The square root of 2 squared times the square root of 2 squared times the square root of 2 squared times the square root of 2. Square root of 2 squared, a 2 and a square root undo, so that leaves me with 2. A square root of 2 squared undoes, so we're left with 2. So far it's 2 times 2. And a square root of 2 squared, or 2 squared taken the square root, that is undone, so I'm left with another times 2. Can I simplify the square root of 2? No. So what does all of this simplify to be? 2 times 2 times 2, 8 square roots of 2. A question was asked earlier, is number 6 already simplified? No. What's the square root of 1? What's the square root of 4? Break it up. And the square root of 1 is equal to 1. The square root of 4 is equal to 2. Okay. Now, for the sake of time, we're going to stop here. Your homework is this homework section. I will let you choose 12 problems. Maybe don't make it the first 12. Those are going to be the easiest 12. So maybe do a couple from the end. Okay? Choose 12 problems. That's it for today's lesson. Thanks for watching, and we'll see you next time.